Good morning, everybody. We are going to get started here in just about 1 minute, just waiting for a couple more folks to sign on. Well, it is about that time. Good morning, good afternoon, everybody. Great to have such a nice group of folks joining us this morning and on such a beautiful summer day. Hopefully it's a beautiful summer day wherever you are as well. My name is Tammy Polanski, and I'm the Marketing Director at the Manufacturer and Business Association. And I'd like to welcome all of you on behalf of our board, our president, John Cray, and our entire staff to today's Artificial Intelligence Impact Briefing. Now, we've obviously changed things up a little bit this year just to keep everybody safe, but we are so happy to see all of your faces virtually today. And we want to do just a little bit of housekeeping and remind all of you that the question box right on the sidebar of your screen there, please feel free to use that during the presentation today. If you have a question, we're going to be doing a Q&A a little later, so feel free to type out your questions and send them over to us. Well, before we get started, I want to thank, of course, our Business Magazine staff. They are the reason we're here today. The Business Magazine does such an incredible job putting on these impact events for us each year. And so I've got to give a special shout out to our executive editor, Karen Torres, our graphic designer, Christine DeSantis, our computer and digital media specialist, Casey Nalen, and our account executives, David Thornburg and Frank Mailer. Great job, guys, as always. And of course, I want to take a moment to recognize two groups who have really gone above and beyond in offering their support to make this event possible for all of us here today. First, let me thank Penn State Behrend and the Penn State Behrend School of Engineering. I have to tell you, they are such great people, and we always look forward to working with them on events just like the one that we're having today. And I especially want to extend our sincere appreciation to a new sponsor of today's virtual event, Neff. Neff is a fourth-generation, family-owned high-tech distributor with operations in 14 states, including 10 distributor locations, one of which is in Lancaster, Pennsylvania, and they have 6 value-add centers, one of which is in Pittsburgh, Pennsylvania. The Neff team provides automation solutions to enhance their customers' competitiveness. So when a business calls, maybe for custom designs, assembly, manufacturing services, machine performance enhancement, software development, R&D, or technical support, the Neff team is there to help. And I know we've got a lot of them watching us here today and joining us. So welcome to the Neff team, and thank you so much for being today's Impact event sponsor. Great to have you with us. Well, ladies and gentlemen, I think we can all agree that this past year has been extremely challenging for all of us. And for those of us operating in the business world, we have certainly had to hone our pivoting skills and our adapting skills, have we not? You know, one of the most fascinating developments has been the evolution to a more virtual world, right? And although we obviously love our face-to-face time, we have all found that there are benefits and opportunities that come with virtual learning and accessibility. And we've also realized the increasing importance of staying current, right? Staying current when it comes to technology. Now, while we don't yet know what's coming right around the corner, we certainly know more today, more knowledge than we did in March of 2020. Certainly true. And we realize that if we are armed with the right knowledge and with the right resources, that we can all put our organizations in an even better position for what comes next. Which brings me to today's topic, artificial intelligence, or AI for short. Now, it's interesting when people talk about AI, you think of movies like 2001: A Space Odyssey or Terminator, lethal robots with kind of a mind of their own. So then you think, well, is AI the good guy, the bad guy, or just misunderstood? Well, what we do know is AI is enabling companies, maybe like yours, to work smarter, work faster, with significantly less resources. In fact, researchers project the global artificial intelligence market is going to reach $733 billion by 2027, just 6 years. That's incredible. And it expects to expand that at a compound annual growth rate of 42.2%. Amazing. So how can we maximize AI in our own organizations? Well, ladies and gentlemen, you are in luck, because today our speaker is here to explain the link between artificial intelligence and data, and the increasing need for cybersecurity, especially in advanced manufacturing and other industries like healthcare, finance, education, gas pipelines, and many more, I'm sure. Dr. Timothy Kurzwig is the director of the School of Engineering at Penn State Behrend and a professor of electrical and computer engineering. Dr. Kurzwig holds a doctorate and a master's degree in electrical engineering from the University of Pittsburgh. He has a bachelor's degree from Penn State. He has served as principal or co-principal investigator for approximately $9.5 million in funded research. He's also published more than 80 journal and conference papers and holds multiple patents. Sounds like a pretty smart guy. Before joining Penn State Behrend in July of 2018, Dr. Kurzwig served as Vice Provost for Undergraduate Education and Professor of Electrical and Computer Engineering at Drexel University in Philadelphia. At Penn State Behrend, Dr. Kurzwig leads an engineering school with 1,600 students and a top 50 national ranking, according to US News and World Report. So ladies and gentlemen, without further ado, we're so pleased to have him with us. I welcome our speaker, Dr. Tim Kurzwig.
Tammy, thank you so much. It is a pleasure to be here today. And I know just the partnership that is between Penn State Behrend and with the Manufacturing Business Association on a business side, on a technical side. It's just one more example of the great things that we can do together. We love being part of your opportunities that you're giving to all of your clients, and that's really important. So thank you for helping me get to meet you and meet some of our new colleagues here today. And let me tell you a little bit about artificial intelligence. I think as we think about artificial intelligence and this idea of manufacturing, what a great combination. There's just tons of opportunities that we're going to talk about today. So I'm going to try to give you a little bit of a high-level approach. We'll give you a little nitty-gritty when we get there. But with that, let's get started. So I think when we think about artificial intelligence, what do we hear, right? So all of this, what we really get is from the headlines. That we're going to unlock different values. We've got impacts for the manufacturing industry. We've got big names. We've got Google. We've got MIT saying, hey, look at artificial intelligence. This can help your company. We are looking at other types of impacts that all of our businesses are going. And then, of course, this idea of Industry 4.0, we hear so much about this. So artificial intelligence, it's everywhere we're looking. We're seeing it, and in fact, it's going on all around us, and we probably don't even realize it's happening sometimes. Let's start with the punchline. Tammy even alluded to some of these, right? What are the benefits? Why is this something that we're even kind of interested in today? And you're thinking, well, maybe I've got some examples in my company, but maybe I'm just trying to find out a little bit more. This idea of data-driven decisions, artificial intelligence, machine learning, and that's a term that we'll talk a little bit about too. What can it do? It's this idea of reducing costs, increasing our productivity, optimizing the operation, saving time and dollars for your company. But what I like best about this is that I think artificial intelligence gives you that opportunity to focus your best people power to what they do best. Where do we need that human interaction? Where do we need that human thought, decision-making, creativity? That's where the human should be playing in that space. And some of the other spaces, maybe artificial intelligence can help us get there. So you're probably saying, all right, Tim, sounds great. Where are we going with this? What is this artificial intelligence? What is this machine learning? Tell us a little bit about that. So, all right, here's my academicness in me. Let's start with the dictionary. Yeah, and it's a dictionary. I know it's this paper book. All right, fine. I looked it up on Google as well in the dictionary, Merriam-Webster, and it's a noun, and there's how we say it. And artificial intelligence. Let's see what this tells us. Maybe this will unlock all the powers. A branch of computer science dealing with the simulation of intelligent behaviors of computer. Doesn't tell us anything at all, right? There's this capability of a machine to imitate intelligent human behavior, maybe a little bit there. Let's see how we do with machine learning. Again, back to the dictionary, what does this tell us? I find this first definition actually starts to tell us something. It says the process by which a computer is able to improve its own performance by continuously incorporating new data into an existing statistical model. Actually, there is something really there, and we're going to help you understand that over our next couple of slides here. But this idea of artificial intelligence, machine learning, these ideas get interchanged a lot. And a lot of it is, the way I think of it is, artificial intelligence is the process where machine learning is the algorithm that's helping us get there. Okay, so you're saying, great definitions, Tim. How does this really work? And I think this is one of the biggest takeaways. And if we think about, and we did that example of 2010 Terminator, right? This idea of learning, okay, we still have to participate a little bit in this learning, and I'll tell you a little bit about this. But the idea is, can we combine this large amount of data, right? We now can sense everything. Can we take all of this data and do processing on this through different intelligent algorithms, such that we get an outcome that we can start to learn from that outcome and see what's next for us. And I thought the best way to explain it is actually through a little block diagram here. And the idea is, okay, let's start with an input. Let's start with all the data. If we can sense anything about our company, and I don't even care the application right now. All I want to do is sense or gather data. And maybe for some of your companies, this is ideas of sensors or IoT, Internet of Things, a big type of thing. But this could be Facebook data. This could be Google data. This could be any type of data. It might be, what is the weather outside today? That type of data might be fed into a machine that can help us make some kind of decisions. And then from those inputs, what are we going to do? We are going to start processing this. And we are going to start making links that might not be obvious to just our human eyes. If we have a statistical data here and statistical data here, how do these things merge? So we need to write algorithms that can help us interpret data, extract the important parts out of that data, make predictions, make actions of this. But there's a key part here that people are forgetting. This starts the learning process when you think about machine learning. And that's this idea of training. You need to make sure that you train this data, train the processing, the algorithms, such that it can make predictions for you. So we can't just start with this empty box, right? We have to give some kind of inputs into that, such that we can get started. Okay, so maybe it's as simple as, it's raining outside today. We're going to train this. We should take an umbrella to work with us. There needs to be something that's going to kickstart this. And then the processing makes some decisions and you get your output. I don't care, again, what that output is. We'll talk about applications and we'll talk about manufacturing applications also. But what we're going to do is look, was our outcome successful or was it a failure? And now we're going to take that output, and here we go. We're going to start closing the loop here a little bit. We need to assess this. We have to say, how did it work? Let's analyze our results. Let's get some feedback. And now back to this learning part. So now we have learning adjustments. We've got to think about our data. What did we learn about our data? What kind of algorithms that we do, that we come up with this? And maybe something goes back to our inputs and say, oh, can we gather other types of data? But this is really the special sauce here of all this AI learning, is can we update our training model? Can we update databases? Can we update whatever it is that it might make a different, more intelligent decision the next time? So this updating the training model, or hashtag learning for the kids out there, this is the important part of all of this. Can we do something within the retraining of this? And this is machines getting smarter. This is now, they have more experience, more data, just like we think of humans, right? The more experiences we get, the better decisions we're going to make. Here's this type of learning within a computer. The more experience, the better our training is, then the more accurate our results can be. Okay, so if we look at this, and this is what I call AI, right? Is this idea of this learning process, processing in the learning adjustments, if you will. So I kind of consider that artificial intelligence. And then I think about the algorithms that are inside these boxes. This is the machine learning. This is the part that we do it. And there are algorithms that already exist. You don't have to recreate the wheel. If you're thinking about artificial intelligence and how would I get this into my company, you're not recreating the wheel here. There are standard algorithms that you can use on a lot of different data. And so my own experience, I've been funded in my research really quite well. I was doing a lot of biomedical devices, and I was looking at my lab goals with my students and my colleagues were biomedical sensing, which is completely battery free and completely wire free. So something you can put onto the body, it doesn't need a battery, I can still detect things. And it was all based off of RFID technology. This is a whole lecture for another day, so I'll skip past it. But I did use machine learning. He said, wow, how's machine learning going to come into this? And I used these exact algorithms of linear regression. That's exactly what I used to make sure that I was getting the accurate results. So one of the applications I was doing heartbeat monitoring for infants. And again, it was just a conductive piece of fabric and a little circuit in there that I was using. But I had to make sure that I was really detecting each of the heart rates. You might say, oh, that's easy, right? So once you get one, you just know when the next one's coming or you'll listen. But guess what? Babies move. And it was infant monitoring. The systems are noisy. So I could learn, I could train this model to say this was a heart rate or this was not a heartbeat. And I would continue to learn this process. So it's just one application of using machine learning on biomedical sensors, something that you might not even think about. And that's my real experience with artificial intelligence and machine learning. That's where I really started my own knowledge about how to use this. So now the idea is all of these different things are out there. All these different techniques are out there. The process is the same. The algorithm might change just based on what is your need, what is your application. So the idea of who's using AI, again, the beauty is the process doesn't change. This whole little loop pretty much is going to stay the same. Maybe some of the algorithms are going to be a little bit different. Maybe some of the data is going to be a little bit different, but all different types of applications are possible. So I said something with healthcare. That's a starting place, right? But all different companies are type of using it. Finances, robotics, Tesla, right? In their self-driving car, there's so much machine learning on this, such that they continue to do these self-automated cars. Really quite cool work there. Media and entertainment, sure. There's all these what are they called? Deep fakes, right? Where they can almost put a different image on a face, and that's all machine learning to make sure that they're doing it right. Education, sure. Commerce, gosh, Amazon, right? To Amazon, you go there and you're searching something, and then the next day you're getting suggestions of the next thing you're going to buy. It's trying to learn about us all the time. Social media, right? And that's one of those pretty current topics right now with Apple and Facebook, and are they allowed to track you as much? That's the input data into their machine learning, such they could suggest things for you or know some things about you. And it's growing all the time, the different types of applications that are going to be there. And of course, manufacturing, right? And that's what we'll focus on for the rest of our little time together here. This idea, how can AI help manufacturing? Are there opportunities for yourself? Are there opportunities for your company or even some of your partners that maybe some AI solutions can help you? And today we're not going to go into specific things here, but I will give you some examples, and maybe it will start just the thought process of how AI could get you involved. Now, when you think of manufacturing and you think of AI, of course, one of the things that probably comes right to your mind is this idea of Industry 4.0. In Industry 4.0, to be honest, everyone has their own definition of what that means to them, and probably how it's implemented in your company, if you're implementing something at all. But remember what Industry 4.0 is. And again, as I said, everyone has their own definition. It's a lot of the cyber physical interfaces, right? How does the computer power work with some of the physical nature of your company? How is the Internet of Things? Can we sense everything? How do we use all of that idea of a smart factory? And one of the things that you'll see here on my slide is the benefits are exactly the same, right? Just like the same artificial intelligence algorithms can be the same, the benefits can be the same to you as well. This idea of reducing costs, increasing productivity and time, and focusing that best power. So let's dig a little deeper into manufacturing and artificial intelligence, and let's see what maybe it could mean to you. Now, a lot of this comes to that smart factory. And when I think of a smart factory, for me, what I think about is this idea of predictive engineering. And I think this is almost an engineering field in itself as we get more familiar with data analysis, when we think more about data sciences. How do we interpret data and how do we make decisions from data? That's my idea of predictive engineering. And anytime we're predictive instead of reactive, we are helping ourselves, and we're probably able to reach some of those benefits that artificial intelligence can get to. So I think when I think of as in my role as director of the School of Engineering here at Barron, I want to be thinking about predictive engineering. How can, and I don't care what the major is, how can we help our students understand learning from the past such that we can predict the future? And in the manufacturing space, this predictive engineering probably goes into a couple areas that are really of concern to you. This idea of running safer, detecting faults quicker, not even detecting faults, maybe predicting faults, quality control, cost optimization, thinking about your supply chain. All of this stuff can be affected by artificial intelligence. And there's some new techniques in here beyond artificial intelligence and machine learning, this idea of digital twins. And digital twins is something that's becoming, again, a bit of a buzzword. And it's this thought where you have a completely simulated version of your plants, your actual physical plant. So this is the twin. And the physical plant actually feeds the simulated system, right? And you can try things over in that simulated system, and that simulated system can actually give inputs back in the physical system. So there are some really interesting things about having a digital twin and learning through the digital twin before you actually get it into the actual production, which is pretty cool. Okay, so we talked about this smart factory, and again, all those benefits, and we've mentioned the challenge, but we'll make it painfully obvious, right? It's this idea of data. What data do I want to collect? How am I extracting information out of this? Just the gigabytes, maybe terabytes of data that you are collecting every day, maybe even every hour. If you sense everything, gosh, is there such thing as data overload? And in fact, I think there is. But one of the things that you can work with data is using artificial intelligence, machine learning. How can I take these mountains and mountains of data and extract those good things out? I thought the best way to help us understand this is use three different examples, and I want to make sure I'm very clear here. This was from Capgemini Research Institute, and they actually published something in Forbes magazine. So I did borrow some of their pictures that I put here, but I thought where I could help us understand this is talk us through the process. Remember that process that we talked about, from the inputs to the learning to the outputs and then feeding this back. Let's look at a couple of these from Capgemini and see if we can hopefully learn some of this process. Again, how we're closing the loop, and in fact, how we're really learning here. So we're going to look at some computer vision quality control, just an example of that, predictive maintenance, and then a machine learning based demand planning and forecasting. And I think you'll see some common threads throughout all of these things in three very different examples. So if we take that first one, let's look at this computer quality control, a vision control. And just to set the stage here, and probably something that you can imagine, maybe some of you folks are actually using vision to check your quality, right? So if you have a whole bunch of parts, right, and it's coming down a conveyor belt coming to a robotic arm, and that robotic arm is going to do sorting for us, right? And the sorting is going to be based on a picture, a vision. So it's something, if it was a human, and at some point this was an assembly line, we would pick and place, and kind of makes you think of the old I Love Lucy with the conveyor belt and the chocolate and trying to get the right things out here, right? Of course, now we've got robots doing this, and it can do much quicker, It could do much faster and hopefully even more accurately than humans maybe could do as well. So if we have a whole bunch of parts that are coming down this, how is that computer going to know which ones do I want to put in a good pile and which one do I want to put in a bad pile, for lack of better words? And again, it's going to come down to a machine learning, right? And one of the things that we talked about is the key part of this is that we first have to train the system. And how would we train a system like this? Well, we would take good parts and we would take snapshots of this, maybe from all different angles, maybe flip it around, twist it around, all different angles, that camera, because that camera is going to be in one position, it's going to take it down, it's going to have to make a decision very quickly. Is this something I want to keep, or is this something that I want to discard? So this idea of training the system comes into place with just thousands of images of what is good and what is bad. And then it starts. The sorting algorithm is going to do this, and it's going to say, it's going to take a snapshot. And again, I've seen this work on maybe some of your actually own companies. I've been lucky enough to visit so many of the great MBA partners and look at what they're doing and how fast things are moving and how their visual systems are taking a snapshot and within a fraction of a second deciding is this good or bad. And that's what we would want in this example as well. So, and it might be using an image database. Great. It's going to do that. It's going to decide, hey, did I get it into my good pile, my high quality parts, or my defective products? And with good training, maybe it works perfectly. And at this point, you're very happy with how this is working. You say, you know, this has worked, this for my needs. But there is a learning possibility here. Maybe when you start this, you find, oh, there's a defective part within, I'm sorry, there's a good part within my defective bin, or vice versa. There is a defective part within my high quality parts. Can I learn from this? And indeed you can. So you might go back and feeding back into that algorithm. Again, very simple example, but it shows some of the power. Now I have more data to put in this. I had a part here that was said, it was a defective part, but it was placed into this. And here's a human part. A human has to identify and say, hey, this one is wrong. It can go back into all of its images that it had. It could say, why was this one deemed that it was a good part when it was defective? So it has images that are stored that it can continues to learn from, right? This idea of learning. Or in the defective part, we have that one good part. Can we learn from that? Let's go back to our images. Let's now put this into our database and say, hey, this one really was a good part. We're not exactly sure what happened. Maybe it's a slightly different angle. For whatever reason, it couldn't match that up, and it got into our division. So benefits, absolutely. Benefits come from this idea of reduced cost for quality assurance. If this is learned well enough, yeah, it's really done its sorting quite well. The reduced cost of looking at inspection, this just overall improved output. This is really the example, a great example of artificial intelligence and how it can continue to learn from that first set of data that said something was good and something was bad. Predictive maintenance, and I know I've even talked to many of the MBA partners about this, is how can we think about some of our machining? You know, in this area, we've got just so much manufacturing, with plastics to metals to all different types of things. And can we know when a machine is going to go down? Because you all know the cost of that, right? And you've shared this with me. You've said, you know, when a machine goes down unexpectedly, this really hurts. Many of our companies right here in Erie are running 24/7. They don't want any downtime as much as possible. And then unexpected, and if a part's not in stock, oh my gosh, we might be down for days. So this idea of predictive maintenance, can we predict when something might go wrong? Again, artificial intelligence can help with this. And in fact, what's interesting about manufacturing, and I'll show this stat a little bit later, this is one of the biggest areas that manufacturing is working in within artificial intelligence, is this idea of predictive maintenance. So again, we're going to train the system. We're going to train the system that's used from the past, and this data could be anything, right? It could be something that is audio, a microphone sensor. It could be something that is visual. It could be something about performance of the output product. It could be something, just someone says, hey, something's going on here. That could actually be an input into this. All these somewhat seeming unrelated inputs. Maybe the humidity is one. Maybe it's the temperature of the device. Maybe it's the outside temperature. All these different, maybe seeming like unrelated inputs put into the right algorithm these are things that us as humans, it would take us a really long time to try to figure out maybe some relationships of what looks like unrelated items that could lead to some predictive maintenance. And then we sensing. We have to put if it's the temperature on the piece of equipment, or if it's other types of data, we need to sense it. This sensing then goes into all of this type of work. And in this example, they're saying this doesn't have to be done locally. We don't have to invest lots of processing powers, computers, all these things. Maybe all this stuff goes right to the cloud, and the cloud can have algorithms running in the cloud too. It's not just a data storage. Clouds can do processing as well. And all of this can go straight into a decision-making algorithm. Again, this algorithm might be putting together some unrelated inputs, at least in our eyes, what might be unrelated to something that really could make a difference. And again, benefits are obvious, right? We could start thinking about optimal times. Maybe this predictive algorithm could actually order a part for us. It can identify the key drivers, and maybe it says, you know, you're running this at too high of a temperature. All right, here's something we can learn from, and could we actually rethink about how we are manufacturing something that could lead to better equipment or longevity of equipment life. And then it says feedback. How do we get this new data into the system? Again, we've completed the learning process, and it continue to learn and complete. Benefits, almost pretty obvious, right? We can lower the maintenance costs. We can have the parts in-house if something needs to be switched, traded up. Hopefully avoid or at least reduce the loss of time that it takes to maintain something as well. So a lot of benefits. Last example, and I know, again, these are very high level, but again, hopefully it just starts to get you thinking. This is this idea of demand-based planning, forecasting, and this idea of taking all types of different inputs and putting them into an algorithm. And again, to us, maybe they seem unrelated. Maybe this is one that we use historical sales data, but we also use weather data and social media data. Maybe there is something went viral, and we can learn from these types of things. Maybe there was a mention of your company on a post. Is that some kind of inputs that we can put into something that says, hey, we maybe need more product at this time to compensate for that, using financial data, macroeconomic data. It's just an example of all of this data can go into these algorithms, and these algorithms again can make ties that maybe we don't see. And that's one of the really neat things about artificial intelligence, machine learning, and then to be able to gather that data back up. Those are the wins. So again, step one, just train the heck out of this, and a lot of training is just giving the data to this. Algorithms exist that can be able to process data and put things together. And then it's the current inputs into the system, right? And what is that output? So here are the current inputs now. I've trained this data. Here are the current inputs. I got tagged on some information. It's 80 degrees out and sunny out here in Erie. Maybe it seems unrelated, but then there's historical data, and I can know how much product that I need at a given time. And again, the benefits are obvious. It's high level enough there that we're looking at, you know, can we get more revenue out of this? Can we have the cost savings when we need to make sure that we're cranking things out, or when we know that maybe it's going to be a little bit slower? Maybe we can reduce waste out of all of this thing. Again, it's this idea of feeding it back into the machine learning algorithms that say, this is where we learn. This is it, right? We're not making the robot from Terminator coming back. We're just trying to educate the processor. We can make better decisions going forward. Tammy did a great job of mentioning some of the market information. And in fact, gosh, you can look out there and there's predictions for everything. And what's a couple $1 billion amongst friends when they talk about some of these predictions? And I'm sure you've seen them, right? And I'll just kind of give a snapshot without investing too much time on any of these. But the theme and the trend is exactly right. You see the growth potential, and you see that folks are integrating this into their system. So up to 16 billion by 2025, and an expected growth of almost 400% in AI and manufacturing. And then there's another one that says, oh, it's going to be $3.7 trillion of contributions into the manufacturing industry by 2035. And then there's more market values saying, well, gosh, look at this exponential growth, right? It's not even linear growth. I think you can almost find a statistic for anything that you want to see in this. But all of these statistics, and as I was preparing for this talk, I was trying to read some of these, and everyone was a little different. And as I said, what's a couple billion amongst friends here? But what you really see is this trend, and it's not just this linear growth. It really is an exponential growth of possibilities and potential impact of the AI market within manufacturing, but of course in many, many different types of industries. And those numbers will change for different industries. Maybe healthcare will go much higher, but obviously in manufacturing, there's a need and there's a sense as well. One of the things that I get asked about a lot is artificial intelligence drawbacks. Right? What is there something that I should know here? What do I not want to do, or is there anything I should be concerned about? And yeah, let's take Hollywood out of this and makes for great movies and of things like that. But let's try to really say some concrete examples here. There is an expense, absolutely an expense in time and expense in actual dollars of making that AI investment for different companies, right? Maybe it's going to be a lot of dollars that is spent on sensing, maybe it's on processing, maybe it's cloud and cloud algorithms that are going to do everything. There is definitely an expense, and every single one of you, as you maybe evaluate your own readiness level for something like AI, you've got to be able to balance that cost versus benefit, and that's something that will be unique to every single company or every single person that is making some of those types of decisions. One of the big feedbacks I get a lot is, well, gosh, are you adding to unemployment, or are people not going to be able to get jobs? And I understand, of course, where that comes from. But what I think is we need to learn to use humans where humans need to be used. And I hope some robotics and AI takes people out of dangerous situations, right? And there's no need for someone to be in a dangerous situation if a robot can do something like that. One of the arms to do something. I mean, gosh, I've seen some furnaces at your places. I've seen other types of things. And let's just keep people out of there. But I think it allows people to have that, what humans can do well, that thought process, that decision making. And I think that's really important. But along those lines, people might need to be trained in different fields. There's going to be more human-computer interaction as well, and how do we deal with that? Social manipulation. Gosh, social manipulation can change ideas of AI. And what do I mean by social manipulation? This idea, gosh, dare I even say a fake news type of idea, right? Can people artificially change different inputs in the system and make different types of effects? But of all the drawbacks, and I do see expenses being a real one, potential jobs lost, sure, absolutely. But I think this idea that some folks would blindly rely on AI, that is the biggest drawback. I think we potentially lose that idea of creativity of people. And maybe AI thinks, well, this is how it was trained, and I keep retraining things, but that is the direction that it's going. I think people and the creativity of people and looking at technology might rethink there are different ways to achieve goals. And I think if we just say AI I've implemented, it's the best way to do it, that would be a mistake. We always need to reevaluate. Maybe we change algorithms. Maybe we do something still based on AI, but blind resilience, in my mind, is one of the biggest challenges. And of course, this idea of cybersecurity and cybersecurity. Wow, we could have a whole hour together on cybersecurity at some point, but it's on everyone's mind, right? In just the last week, we saw cybersecurity attacks on the pipeline, right? From Texas up to almost the Virginia type of area, and we saw real effects from this. Obviously, things were shut down. We saw real effects even here in Erie, right? All gas prices went up, looked like almost 10 cents across the board on per gallon of this. And I do see this as a direct relation to all of this. Cybersecurity is really important. And especially anytime we're talking about data, and then, gosh, that's one word that we probably said a lot about is data and different inputs into the system. We have to make sure that we're being secure. Every time we're thinking about cloud analysis, right? Gosh, data leaving your own home company and coming back with some decision making. Sure, I think cybersecurity is really quite important. I did a little research on just cybersecurity in manufacturing. And albeit this is a little bit old, there are some takeaways from this. And again, instead of looking maybe directly at the numbers, I think what I see here is manufacturing is a little bit behind on cybersecurity. It's some things they haven't thought about before. However, I see a good note in this also, is that manufacturing is aware that they're behind and they're catching up very quickly. And I think that is something that's really important. We'll talk about how to maybe get started in AI in a couple slides here. But I think cybersecurity and AI are going hand in hand, and that's something that's really important. Adoption trends are interesting, right? And I think we see AI in the news, machine learning in the news all the time, and I think we all see the benefits of these. And in fact, the adoption rate, it's interesting. There's a state of artificial intelligence. There's a lot of different articles out there. I found this one to be pretty encompassing, meaning that they were looking at all different types of industries, and they were giving some really neat results. So if you're interested, it's this Mckinsey global survey, just called the State of AI. That's what the cover looked like, and it was pretty nice, just from November of last year. And of the folks that they responded, 50% of these businesses have been adopting some AI in some function of their business. And maybe it's just on a social media side, or maybe it's on something else, or your marketing side, something like that. But there is a lot of interest and growing interest in this as well. I was interested in looking at manufacturing in particular, and I dug through some data. And the top two things where people are using manufacturing is in yield or throughput of optimization, one of those types of examples that we looked at, and then predictive maintenance as well. So those are the bigger two right now in manufacturing. I'm sure others will be coming up as well. So adoption, I think it's a little bit steady. However, the technology development is moving quickly, and industry and academia. And now maybe how this comes into my space a little bit is that I think we need to be thinking about how we're educating students. And in fact, that's where we do spend a lot of time on this as well. And just as an example, out of the academia space, there are just lots and lots of resources here. I just highlighted two here. A really interesting book came out a couple of years ago from the president of Northeastern University up in Boston. This idea of robot proof, and how do you make degrees robot proof, and what are we educating our students with, such that you think about higher education, this dawn of artificial intelligence and the future of work. A really interesting article. I would recommend both of these if you're looking for something, both fairly easy read, and the future of work really has a lot of data in there as well. So as in my space, I think about every degree, and you say, sure, artificial intelligence, machine learning needs to be in computer science, software engineering, absolutely. But I actually think all of our engineering degrees need some of this. Our traditional ones, our electrical engineers, our computer engineers, our mechanical engineers, even our engineering technologies. We got wonderful programs here in plastics and in mechanical technology and electrical technology. Everyone needs some kind of aspect. So I think 10 years ago, everyone said everyone needs to program something, some type of programming, absolutely. But now I think we need to even take it to the next step and think, how are machines learning, and how can we help that type of interaction? It's not always the algorithmic program, it's just how to use of that kind of stuff. At Barron, we're starting some new programs, new labs. We're looking at data analytics. We're looking at automation robotics. And I know we have a lot of friends at Barron out here. And this is some really exciting stuff that's coming on our plate really quickly here. I think we have one last role, and that's continuing education as well. Is that you've got a lot of great workers in your workforce who maybe need some continued education on AI, on machine learning, and the use of these things. I think that's our role as well. So I see just a wonderful opportunity. I know when I think of the Manufacturing Business Association, and I think about Penn State, I know you've got a wonderful relationship with the School of Business. I think we've got a great relationship with the School of Engineering too. There's an opportunity here of us all working together, us sharing ideas, making sure that we understand your needs for the workforce, our retraining, and just your experiences as well. And I think we can be helpful in this space as well. So you might be saying, where do you start? Where do I start? You know, a lot of interesting things out there. It's just a couple companies that are doing this artificial intelligence, and I'll tell you, I quickly ran down a rabbit hole here when I started thinking about all the folks that are doing artificial intelligence. And please know this list. I just started capturing some logos, and I quickly ran out of space on my slide here. There are really many companies that are poised to help you get started in some of these areas. Some of the big players, right? You got Amazon cloud services, you've got Microsoft, you got Google there, you've got some processor makers, right? Intel is thinking about this. NVIDIA is graphic GPUs, graphical processing units, and you got robot makers there. You've got all different types of things that are getting into that space as well. And even our sponsor, NEF, I know that NEF is getting into the space and partnering with a lot of these other folks as they are thinking about some equipment as well. So there's a lot of big players there, and I think if you are really encouraged or interested, I think some conversations with some of these folks might have some in-the-box solutions, right? And those are handy, that you can say, hey, this is my goals here, and how do I partner with some of these folks to get involved? So, and gosh, my time goes so quick here, and I just really enjoy talking about this, and hopefully just kind of get you thinking. As I said, we took a pretty high level here, and we focused on these benefits of manufacturing, benefits of AI in manufacturing, I should say, and really coming up with that bottom line. I know I've said it a couple of times, is really using people where people need to be used. Use human thoughts, use human decision making, that human interaction, and that idea of human creativity. Because I think that's one of the biggest skills that we have here that is sometimes lost even in these technical types of jobs, because we need to be able to look at problems in a lot of different ways. That's what humans should be used for. And I'm sure you're looking at your own readiness level. You've got to balance that benefit versus cost, the personnel and training personnel, and your own goals. What can artificial intelligence, machine learning help you type of achieve? And with that, because I do want to see if there's any questions out there, a big thank you. A big thank you to you as an audience for spending a little time with us today. A big thank you to the MBA for inviting me to talk about something that I think is just really growing, something we're all going to benefit. I have my contact information there. It's easy enough to remember, just my last name at psu.edu. Love to hear from you if you got any thoughts or comments. But Tammy, I'm going to pass it over to you, and hopefully there's a little bit of time for some Q&A or just even comments or experiences. We'd love to hear from our MBA members today. Thank you.
Thank you. Thank you, Dr. Kurzwig. That was, you packed a lot of information into roughly 40 minutes. So well done. That was impressive. And I know we do have some questions from our audience, and Karen Torres, our executive editor, she is in the background here. And Karen, I'm going to throw it over to you so you can offer up a couple of questions in the time that we have.
Well, Dr. Kurzwig, thanks for a great presentation. We know there's a race among world leaders in the area of AI. How would you describe Northwest Pennsylvania's positioning compared to others in the United States when it comes to AI research and application?
Sure. I think research-wise, we're there. I really think we are up with a lot of the leaders in doing this type of work and educating students. So on my kind of academic side, I think we're there, and we're continuing to learn and participate in this. When I think about Northwestern Pennsylvania and what is going on with artificial intelligence here, I think it's starting. And I don't think we're totally full blown yet. I think when I think about Northwestern PA and I think about all the incredible manufacturing that is going on right now, I think we're not quite there with AI. I know some folks are doing it. I know there's a lot of different quality inspections that are going on and parts that are going into the good bin or the bad bin, as we did an example. But I think further information on the learning process can go. But I know it's happening also, and I know I won't say names right now, but I do know even some of our local companies, thinking of in particular in some of the plastic companies around here, are working with Barron right now to implement some solutions and learn more about AI and trying to look at some of the two categories in particular. Line with a lot of what we saw from some of those reports was in the idea of better throughput and making sure that the quality is there as well, and also predictive maintenance. So I think there's a real opportunity here because manufacturing is so rich in this area. I think we're not quite up to where everyone else is, but I think we're growing quickly.
Well, and Dr. Kurzwig, I wanted to, you kind of addressed this, but I wanted to get a little bit more information. Companies right now need to make very smart decisions about where they put their investment dollars. What are some very small incremental steps that they can, and universally, whether it's a manufacturer, healthcare, education, finance, make when it comes to improving their use of data application and cybersecurity when it comes to AI, like your top 3 musts?
Yeah, a great question, Karen, and absolutely, I appreciate, especially in a weird COVID year, the challenges that our manufacturers and all of our businesses, no matter what their application is, faced, and a lot of pivoting, as Tammy even talked about it in the kickoff to this session. I think what I would encourage people to do is talk to some of those vendors that we talked about. And I'm not trying, and I won't even say specific folks that I would encourage opening up to. And my guess is probably collaboration across the MBA and people sharing the experiences might be one of the best things. So I would say, step number 1 is talk to other people, because a lot of these solutions, no one needs to figure this out. No one has to reinvent the wheel here. I think there are some real leaders just in this area that have started some of these operations of artificial intelligence, cybersecurity, and I think communication between partners within the MBAs is really the best way to start. And then I think is trying some things. I think there are some lower risk things that you can start. And of course, when you think about your potential internet or data providers, you want to just make sure that they are following all security operations. I think there are things that you can do on your own networks within your companies and making sure your computers are up to date. I know it sounds probably silly, and I sound like when I tell my mom, update your phone and all these things, but really making sure that all of your things are up to date, and that you've got the proper firewalls in place. These are the things that really are some very incredibly simple steps that you can at least help with some of the cybersecurity. Because as much as we think, oh my gosh, this cybersecurity is something much bigger. Hey, what we're learning is that, and even at Penn State, we see this all the time. People are trying to get into our systems all the time, and it's kind of crazy. And we've got so many barriers put up there that no one really is very successful. But people try some weird things, and even you say, I'm just this small little company, who would want to get in? You never know. So a couple of little things is communicate between each other, because I think those experiences are the best. And second, just kind of keep your own technology up to date as much as possible.
And Dr. Kurzwig, from what you researched and discovered through your work, what do you feel is the next big trend in the area of AI, the emerging trend that we should all keep an eye on?
Yeah, again, super questions, and thanks to the audience for thinking of all these great questions. I see almost all of these technologies really bolstering from AI and machine learning. I do think there's a huge benefits in manufacturing, just for some of the reasons that we said today, and I think we saw some of the projections that's there. So we'll always keep our eye on manufacturing, but I think there are a lot of other things out there. I think, gosh, just as anytime we're on the internet, so much information is being collected about us, and you can decide if you want to, now there are some new regulations and new softwares in place that you can kind of limit your own footprint on the digital space. But you see some of the e-commerce is just finding out so much information about us, and this idea of social media. So there will be a big area still that I think they've led the charge, but I think you'll still see a lot of that as well. And then healthcare. I think healthcare is one of the biggest things that we are going to see. People, again, one of the beauties of artificial intelligence is taking in all those different inputs, which again, maybe to us humans seem. And if we can put all of these together, we can let machines look at all this different data in different ways, and maybe make some kind of healthcare decision, some kind of observation that maybe a doctor would have missed, or someone would have missed. I think there are big opportunities there as well. Now, again, with the whole caveat that I shared earlier, is we can't over rely on this too. We still need that human touch. We still need the doctor in the medical example to really make some final decisions. But maybe this can help us with some healthcare options or observations that we might have missed.
Well, Dr. Kurzwig, thank you so much.
Absolutely. This was a lot
wraps
of
up
fun. I appreciate Karen and Tammy. Thank you so much. And to all your MBA members, I really appreciate you, and I really think there's a lot of things that we can do together in that business space and in that academic space as well. So I look forward to working with you on many different future endeavors.
Thank you, Dr. Kurzwig. That was honestly fascinating presentation, and I couldn't agree more. I think the information presented today, and hopefully with our working together with you and with Penn State Barron going forward, we want to bring more events like this to the membership with the kind of topics and information that can really help our member companies with their business strategy, their investment, their growth opportunities, and especially today when it comes to artificial intelligence going forward. So again, thank you so much for joining us. We know busy guy, but we so appreciate our partnership with Penn State Barron, the School of Engineering, and with you for being here with us today. So thank you so much.
Thanks, Tim.
Again, I'd like to also thank all of our sponsors today for their support. To the NEF team tuning in today, thank you so much, everyone. Your support is greatly, greatly appreciated, as is your membership at the MBA. So thank you for joining us today. And of course, the magazine staff, way to hit it out of the park, guys. Great job, appreciate it. Ladies and gentlemen, before we sign off, let me say we want to just truly just remind you of our next impact event, which is going to be Women in Leadership. And that's coming up September 14th. So you're not going to want to miss that. And it's going to be in person. So finally, we look forward to seeing all of you again together in person. So watch your inboxes for more information on that coming forward. Last but not least, summer is here, everybody. So on behalf of all of us at the MBA, we wish you all a very healthy, a very happy summer filled with lots of sunshine and lots of fun with family and friends. So enjoy, everybody. Great to have you with us, and we look forward to seeing you next time. Thanks, everybody.